I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll continue with congruent triangles, understand it in a deeper level. Here is a very important question to think about. Why the two triangles are not congruent if the condition of SSA is given to us? And how do we include many other concepts learned while solving questions, especially when we involve circles, triangles, similar triangles, and Pythagorean theorem? We'll look into all this with our golden girl, Naisha.
Nisha Khandelwal. She is first in crunches, first in push-up, first in sitting ball throw, first in skipping, second in standing broad jump, first in 30-meter dash, first in shuttle run, and second in long distance.
Hi, Naisha. How are you doing?
I'm fine. How are you?
Very good, very good. So, Naisha, in the last class, what did we learn?
We started the chapter of congruence of triangles.
Congruence of triangles. So, did you learn the concepts? Did you understand the concepts?
Yes.
Very good. So, in this class, we are going to review some of our concepts and have some questions based on what you have learned. Okay? That will help you to connect with your learnings and move forward. Is that clear to you?
Yes.
Now, before we begin, I would like you to introduce yourself to everyone. Who you are, from where you come, and why do you want to learn?
Yes. Naisha, I study in grade 8 and I love archery and have won gold in archery. So that's why I'm here to take gold in maths.
Gold in maths is your passion, and let's work on it, right? So let me share with you a whiteboard. We'll keep it very simple and then learn further about congruent triangles, right? So let me begin with the review. We talked about congruent triangles, right?
Yes.
The symbol for congruence is you make equal to and then you make like this, which is for similar triangles, right? So similar triangles are equal. That means they become congruent. Is that okay? So that is how we could connect with the symbol. Is it okay? So congruent triangles are also similar with a constant ratio of 1 because the sides are exactly same, right? That is how we connect. Now, for congruent triangles, give me condition. Let us say we have two triangles. Let me make two triangles here. Let's say we have a triangle ABC and triangle DEF. If I have to prove that they are congruent, then what are the conditions? How can we prove?
By
Conditions.
side angle SAS test and SSS test.
So conditions for congruency, let me write, okay?
And AAS test.
And AAS test. So there are basically 5 tests which will prove that the two triangles are congruent, correct? So that is correct. So you remember that. Now, as you can see from this list of 5, we do not have one condition. So why not? Why not SSA? Why not SSA? What I'm trying to say, if two sides and one angle is equal, why the triangles are not congruent? Why not? Tell me. Because, for example, I can just draw two triangles here. Let's say this is one triangle and we have another triangle. right? And if I tell you that in these triangles, we have equal angle, correct? So, and we have two sides equal. Correct? So tell me why they will not be, they are not, why not congruent? Why not congruent?
Mm.
So what I'm trying to say, if I tell you that we have a triangle ABC and DEF, two triangles. We say angle B is equal to angle E, let us say, right? And we say that side AB is equal to DE. And we also say that AC is equal to DF.
Yes.
We give you these three conditions. Explain why.
Maybe because they
Why
are not the exact size, like
these
one triangle.
triangles may not be congruent. Yes.
Maybe because their size must be different. One must be big in size and one must be small in size.
No. Let us say if I give you the numbers also. Let me pay now. This is your main question. Is it okay? Let me give you with concrete numbers now. Is it okay?
Okay.
Let's clear the screen. Go to the next page. So what I'm saying is I have a triangle ABC and I have a triangle DEF. In triangle ABC, I'm saying that the angle ABC is equal to, let us say, 30 degrees. 30 degrees. And here triangle DEF, the angle is 30 degrees. So I have got same angle, correct?
Yes.
Right? So let me just draw for your convenience triangle ABC. So we have one triangle where I'm saying this is 30 degrees. Okay. And now I'm saying that in a triangle ABC, I have this side which is equal to, let us say, 3 centimeters or let's say 2 centimeters. So let me say this is ABC, right? Okay, so I made this side as 2 centimeters, right? And I'm saying A to B is 2 centimeters. And similarly, I'm saying D to E is also 2 centimeters. Is it okay?
Yes.
D to E is also 2 centimeters. Okay. And now I'm saying that the other side is given to me as A to C as, let us say, 1.8 centimeters.
Okay.
Okay. So if and D to F is also 1.8 centimeters. Is it okay?
Yes. Yes.
So now I have a condition, which is, as you can see, one angle
Yes.
and two sides are given as congruent.
Yes.
Now the question is, are these triangles congruent? Because this is not one of your conditions, right? You gave
Yes.
me 5 conditions, not ASS, or I could write this as SSA, right? Any one of them. We could write like either way. Is it okay?
Yes.
This is not congruent. Tell me why. So I'm trying to sketch another triangle, DEF now. So I'm given one side, which I don't know how long it is. So I'm just leaving it like this. One other side. So I'm saying D, E, and F. So I'm saying this angle here is 30 degrees. And this is 2 centimeters given. Is it okay?
Yes.
So I can make a 30 degrees and cut 2 centimeters. I know point D. Now I am saying D to F is 1.8. So if I connect this with 1.8, let us say, centimeters, I make this triangle. And I'm saying now that these two triangles should be congruent because it looks like, right?
Yes.
It looks like congruent, but still it is not congruent. Can you tell me why it is not congruent?
Maybe
Very
the
difficult
BC.
question, right?
Yes. Maybe the BC line and EF line will not be the same. Will not be of the same measurement.
Maybe you are saying maybe BC is not equal to EF.
Yes.
Correct. Correct. I like this. But you have to tell me how. That is thinking. That is creative thinking. How? So you are on the right path. They are not congruent because maybe they can be congruent also. If I leave it like this, they can be congruent. But what happens if I, now we know that this is not congruent. That is why the thing is, how can this be different? But the side we maintained as 1.8 centimeters. This is what we have to think. Correct? How will you think and how will you do it? So how will you make this as 1.8? You will take a compass, open it 1.8 centimeters and make an arc, right? So wherever the arc cuts this line, you get your triangle. Is it okay?
Yes.
You see it can cut at 2 places.
Yes.
So you could have a triangle which could be like this. So I could have a point F which is not that far but closer. Do you see this F dash?
Yes.
Now I still have another triangle which is having the same dimensions. You see D to F is again 1.8, but this
Yes.
triangle is not congruent to this. Is that clear to you?
Yes.
So if we give you two sides and an angle, it is not necessary that the triangles will be congruent. You get the idea?
Yes.
Very important question to understand. Perfect. Did you see how? Can you explain me now why, with this given condition, I could write this as angle side side, or I could write angle side side, right?
Yes.
Or I could write side side angle. In the case, either way it could be written. Then how will you show? Explain me that they may not be congruent. Tell me.
Because maybe the which segment we didn't have the measurement, they could not be the same. That's why it is congruent. So at that time you have to draw using a compass. You have to draw an arc there and see whether the same measurement is there. And if there is the same measurement, if it is not the same measurement, then they are not congruent.
Got it. Because with the second side given, with the angle on one side, yes, we make one point, and from that point to make the third side, to make the second side equal, as we did this, we have two possible triangles. We have sometimes, we can write sometimes, not always. Sometimes we can have two possible triangles. Is that okay?
Yes.
We call this ambiguous case. We call this, you'll learn later, what is the condition? We call this as ambiguous case. Ambiguous means not sure. We are not sure. Are we talking about DEF or DEF dash? Because there are two triangles possible. We could make this as DEF or even DEF dash, correct?
Yes.
That is why. So we call this ambiguous case. We'll learn soon, later when you learn trigonometry and sine law, what is the condition for having two triangles, right? It is related with this shortest distance, right? If I have a distance which is less than this, you cannot make a triangle. But if I have a distance which is between the longest and this, then we can make two triangles, and that is why SSA is not a condition for congruency. Is that clear to you?
Yes.
So this is a very important test question, where we're trying to test the communication and analytical skills of a student. So you can now analyze the situation and you can provide an explanation that why this is not the condition for congruency. Is this clear to you?
Yes.
Now, after this, let me take another test question with you, which we will again discuss at length. Let me clear the screen now. Now, question number 2. So again, this is again a test question for you. Question 2. I'm making a drawing for you, and you need, so I will make a drawing for you. Okay. Fine. So let me label this. Let me call this as, let me say B here. A, B, C. And let me say this is P and Q. Now in this drawing, I have given you that AC is equal to PQ. Is that okay? Length AC is equal to length PQ as shown by those markings, right? Exactly same. Now, you have to tell me what additional information is required to prove that triangle ABC is congruent to triangle. Okay, let me write PBQ by, let us say,
AAS.
AS, okay, AS. So what additional information is required to prove that these two triangles are congruent by, I have given you condition AAS. Is that okay?
Yes.
If I say SSS, you can say corresponding sides, right? But I'm saying
Yes.
by AAS. Tell me, what additional information you need and explain why.
We need angle ABC and angle PVQ to be congruent angle. There should be a mark here. These both angles are same.
Okay. What else? So
Then,
you want that angle B on both the sides should be equal, right?
yes.
Okay. What else?
And then we can say ACB and P QBP are same.
This angle and which angle?
QBP.
QPB.
PB.
Why not that? Why this?
Because these both are same.
Correct.
ACB and QPP are same angles, and one side we have, so we get the AAS.
Then you get AAS. Now we have angle, side. So now you say this is how you made this as angle, side, right? Now
yes.
they are congruent, right? This is what you say, correct? Now,
yes.
you know one thing, that ABC and PPQ are always equal, right? Because they are
Yes.
vertically opposite angles. They are always equal.
Yes.
Vertical angles. Now, your condition is correct. So you should know, also, you could assume also. I mean, you don't have to be told. But if I even tell you one angle, that this is equal, then also you can show that these triangles are congruent, correct?
Yes.
So in this question, what additional information is required to prove that this is equal to this? So you can always say, we know that this angle is equal to this. They are vertically opposite. Is it okay?
Yes.
In addition, we should know that angle ACB is equal to angle QPB. Is it okay now?
Yes.
Writing both is also correct, not wrong. Not wrong. But writing in this fashion shows that you are confirmed that vertically opposite angles are equal. We know that. So one angle we have taken care of, right?
Yes.
Another angle, we could have selected this one or that one, correct?
Yes.
That was your option, right? So,
yes.
if two angles are equal, the third is also equal, correct? So that means the triangles are similar also from AA. Two angles means they are similar also, right?
Yes.
So now let us link the two things. So what are you linking now? Link, connect.
Parallel lines.
If we say two angles, see, this means AA means two angles, correct?
Yes.
So that means similar triangles are congruent if one of their side is equal.
Okay.
Is that correct? Two angles are equal means three are equal because the total is 180. Any other one side is, if that is also equal, then they are congruent. Because why is it so? Because then the ratio of sides, you can say, we know that AC over PQ is equal to AB over BQ, or you can say QB, is equal to CB over PB, right? And that is
Yes.
equal to 1. Since the scale factor is 1, they are exactly same. They are not enlarged or they are not compressed. Correct? Get the idea? They will
Yes.
overlap over one another exact. You get the idea?
Yes.
Correct? So we connected similar triangles with congruent triangles provided the side, one of the side, corresponding side is also congruent. Then the triangles are common because the scale factor is 1. Is that clear to you?
Yes.
Very good. Now we are doing another connection higher level. So we are going to extend our learning. So let me now extend the learnings. So we just now have connected. What connections have we making? Let's look into the connections, right? We have made a connection from similar triangle to congruent triangle. Correct? How?
Yes.
The connection is that scale factor is 1.
What is the meaning of scale factor?
So when you enlarge, so if I have one image and if I have this image, do you see this is like 3 times?
Yes.
Let us say this is times 3, right? So scale factor is 3. Let us say each side is 1, 1, 1, and now here it becomes 3, 3, 3, correct?
Yes.
So the scale factor is 3. Like a map, when you draw, you have a index which gives you the scale factor, right? Because they are exactly similar. Similar means they are enlarged or they are compressed, correct?
Yes.
But if scale factor is 1, if you make 1 to 1, right, then it is exactly congruent. It will match.
Yes.
You understand this? Now
Yes.
how we are going to connect is problem solving using other concepts. And one of the important concepts we look into is Pythagorean theorem. Do you remember Pythagorean theorem in right angle
Yes.
triangle? What is it? Tell me.
It is like the longest segment of a triangle in a 90-degree right angle triangle, the longest segment.
Right. So if my sides are, let us say, A, B, C. So this side is A, this side is B, this side is C. Then we know that A square plus B square is equal to C square. This is what it is, correct?
Yes.
We will connect with Pythagorean theorem and we will also connect with circle, especially chord. So let's move on and see. Take up an example based on this. So as I was saying, let me make a circle, right? So there's an approximate drawing which I'm going to make for a circle. Okay, that's my circle. Is it okay?
Yes.
Now in this circle, I am drawing a chord. This is a chord. What is a chord? Chord connects two ends on the circle, right?
Yes.
Let us say the center of the circle is right there. So when I connect with this,
Radius.
this is the radius, this is also the radius. Is that okay?
Yes.
And if I drop a perpendicular from this circle, let me label this circle now, right? O, A, B, correct? Let us say this point is P, correct?
Yes.
Can you show, you have to prove, find, if AP is, let us say, 3. If AP is 3, if AP equals to 3 centimeters, find R. How will you find R if AP is 3 centimeters? Tell me. So let's, find A to B. Find O to P.
A to B, it will be 6 centimeter because this both sides will be same.
Okay, so you are saying these will be same. So A to B is 6 centimeters, right?
Yes.
A to B is 2 times 3, which is 6 centimeters. Correct?
Correct.
Now let me just give you one more value here. O. So we know this 6 centimeters. Very good. Okay. Find R. Let me say if OP is equal to 4 centimeters.
Then R will be 4 centimeter.
What will be R if this is 4 centimeters?
R will be 4 centimeter.
No, R is the hypotenuse. So R square will be equal to 3 square plus 4 square, right?
Yes.
R square will be 9 plus 16, which is 25. So R will be equal to square root of 25, which is 5. So using Pythagorean theorem, you could have solved this. Now, my question comes back to one thing, and that is why AP is equal to PB. You said AP is equal to PB. Tell me why.
Because it is 90 degree angle.
You have to prove why.
Because it is given that it is a 90 degree triangle, right angle triangle, so both the sides will be same.
No.
That's
okay. You are right in a way. You have to prove that triangle OPBA is congruent to triangle OB OPB. Do you see that? You have to prove that. I did not say that AP is the midpoint, right? I only said if AP is 3 centimeter and OP is perpendicular to AB, correct? It is perpendicular. So when it is perpendicular, you have to first prove that these two triangles are congruent, correct? How will you prove? Tell me. How will you? You can use one of the theorem, 90 degrees and a common side, right?
Yes.
That can help you. And radius is also correct because radius is same for a triangle.
Yes.
So you can use Hypotenuse-Side theorem.
Side theorem.
That is a condition for congruency, right? Because we know that radius R is same, right?
Yes.
So that means OA is equals to OB, correct? One side. That is hypotenuse.
Yes.
And OP is common.
OP is common.
Is that clear to you? In the right angle triangle, right?
Yes.
OP is common because it is a perpendicular thing. So we will do step number 1 is we'll go to this. Think why AP is congruent to PB. You assumed, right? Here you assumed, correct?
Yes.
And you got the right answer. I'm not saying wrong answer. But what you should be doing? First you prove because you're learning congruent triangles, correct? So first you
Yes.
prove that from hypotenuse-side theorem, these two triangles are congruent. And therefore, this is true. Is that clear?
Yes.
AP is PB. And then you will say this. AB is equals to, then you will say AB is equals to 2 times AP, right? And then you will get the answer.
Okay.
You get the idea? So, when you are given a question, we can jump to the solution. However, it is required to go through systematic steps and then derive at the right result using all the concepts learned. Do you see how we have connected all this now?
Yes.
Correct? So once you prove that the triangles are congruent, then you find that this is also 3 and therefore this length should be 6 centimeters, correct?
Yes.
And if I tell you in addition that OP is 4, correct? If I tell OP could be anything, but if I tell you OP is 4, then R is 5. OP could be anything, right?
Yes.
I could have said OP is 6. Anything I could have said, right?
Yes.
So, based on that, we could have found the radius. Is that clear to you?
Yes.
Correct? Now, let us do another question. And that is the last question of our exercise today. Okay. So, again,
Yes.
I am sketching one circle. And similar to that,
Excuse me, just a second. For 5 minutes, can you wait? I want to change the connection because your voice is not coming so good.
You want to
Just,
change the connection? All right, change.
just 2 minutes. Yes.
Okay. So, in this time, we are given a circle as shown here. And I am drawing a chord AB. So we are saying length of chord A to B is equal to, let us say, 24 centimeter. Now, it is connected with the center O. That is the center O, correct? If I draw a right bisector, we call this as a point P, right? So OP
Yes.
is the right bisector of chord AB from center O. Is that clear to you?
Yes.
Correct? You have to find the radius, or AB is 24, we know, right? AB is 24. Right? Find OP if, let's say this point is M, if OM is equal to, let us say, 5. Centimeters. Find OP if OM is 5 centimeters. So what I've given you here is, this is 5 centimeters. And this is A to B is how much? 24.
24.
Yeah, 24. Tell me, how will you do it?
Hmm.
Step 1. Use your concepts of congruent triangles and then start doing.
So we use hypotenuse-side test.
Okay. So you will prove that triangle OMA is congruent to triangle OMB, right? Using hypotenuse side theorem, right? Because we know that this is the hypotenuse, which is the radius R, is same, right?
Yes.
So we are saying R equals to R, and we are saying OM equals to OM. Is that okay?
Yes.
Common side. So whenever you have a common side, one of the side is same of the two triangles. So they are congruent, correct? If they are congruent, then what do we get? We get that these two sides are equal. M is the midpoint, right?
Yes.
That means that AM is equal to BM. Is it okay?
Yes.
So we write this as this implies. So we know this. So that means next step will be, you will say what? AM is equal to how much? 24 divided by 2, which is 12 centimeters. Is it okay?
Yes.
But straight away you will not say, because I did not tell you they are congruent. You have to show that they are congruent. Otherwise you lose 0.5 marks. You get the idea?
Yes.
Now you know 5, 12, and you can find R. So now use Pythagorean theorem. So you say R square is equals to 5 square plus 12 square. How much you get?
R square is equal to 25 and 144.
So what is square root of 169?
169.
13 centimeters, right? You should remember
Yes.
these up to 15, all the squares you should remember. Make a table, learn all these squares up to 15. Is it okay?
Yes.
Very important. So you know OA is, what do you have to find? You have to find OP. How will you find OP? What is OP? Now tell me.
OP is 24 or 19. 24 minus 5, 19.
OP is also equals to radius, so it should be also 13 centimeters. You see, it is also a circle radius, right?
Yes.
It is same as OA, because if you are making a circle, all the three are radius. You see that? So it's kind of tricky. Sometimes you do not see it properly, but now is it visible?
Yes.
So that is how you will find OP, which is also radius, right? It is same as OB or OA, correct?
Yes.
Right? So that is how you will solve this particular question. So do you understand how now we used hypotenuse-like theorem to prove that the triangles are congruent and then solve questions related to chords within a circle, right? It is not an easy question. It is a difficult question. You get the idea?
Yes.
Do you see these kinds of drawings and can you solve such questions now easily?
Yes.
Okay. So that is where we will end our today's class, right?
First, always you have to use the theorem, and
Yes.
then we have to go to Pythagoras theorem, right?
Yeah. Because if I have not told you that they are congruent triangles, you have to show that they are congruent triangles, correct? Then
Yes.
you have to say that AM is equal to BM. Then you can say 24 is divided equally into 12 and 12. And now you can use the Pythagorean theorem to find the hypotenuse. And the other side, OP, is also the radius, and therefore it should be equal to 13 centimeters only. You get how do we communicate about it? So that is what we see, thinking and communication skills. So that improves your communication. Is that okay?
Yes.
So you need to analyze, communicate, think, and then solve. Perfect?
Yes.
That is mathematics, not just giving answers, right? Not just giving answers. Now we have good foundation, and that should help you in perform well in your test, right? So the idea of gold will be true soon, okay? So let me
Yes.
stop sharing this particular page. And once again, I will like you to summarize today's learnings. So, Naisha, can you summarize what did you learn today?
Yes. I learned how to solve different questions and how to answer by using Pythagoras theorem and where to apply what theorem. Then we learned the circle triangle thing. In a circle there is a triangle, how to do solution to it. Yes.
Very good. So, you also learned today how do we connect our learnings. Earlier, you knew that similar triangles are when we have two equal angles, right? But similar triangles may or may not be congruent. They could be enlarged or they could be smaller. However, if their scale factor is same, that is to say, if they have a constant same one side length exactly same, in that case, they are also congruent because then the scale factor is 1, correct? So
Yes.
that is first thing. Second, if we are given triangles within a circle, we could actually solve them using the combination of Pythagorean theorem with before we have to prove that they are congruent using hypotenuse-Side theorem. And then we can
Yes.
apply Pythagorean theorem to further solve it. So in this way, in today's lesson, we have connected the concept of similar triangles, congruent triangles, circle theorem. That is the circle theorem which I was talking about, right? Understanding chords and Pythagorean theorem. Do you like this part?
Yes.
Okay, then. So we'll end the class here today. Thanks a lot and see you next time. All the